Now in this lecture we answer two questions. In the first question, we'll find out the length of this line segment AQ is equals to x. We have to find out the value of x. And in the second question, we'll find out the area of this quarter circle AOB. So we'll start with the first question. In the drawing, we have semicircle ADCB. You know that this is line segment QC. That is equals to 6 units in its length. This is called BC. That equals to 5 units in its length. This is angle PQC. This is the right angle. In addition, we know that arc PA equals to arc CB in its length. Those two arcs are equal to each other in their lengths. Again, our task is to find out the length of this line that AQ is equals to x. We have to find out the value of x. So first of all, we can implement rule 7. So I think we have rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle or a semicircle, then it is equal to 90 degrees in its size. In the drawing, we have a circle. This is peripheral angle ACB that subtends on chord AB. This is the diameter of the circle. Therefore, according to this rule 7, peripheral angle ACB must be equal to 90 degrees in its size. So according to rule 7, any peripheral angle that subtends on the diameter of a circle or a semicircle must be equal to 90 degrees in its size. So we can implement rule 7 in our drawing. In our drawing, this is peripheral angle ACB that subtends on this chord AB. That is the diameter of this semicircle. And according to rule 7, any peripheral angle that subtends on the diameter of the circle or semicircle must be equal to 90 degrees in its size. This is AB is the diameter of the semicircle. Again, according to rule 7, peripheral angle ACB is equal to 90 degrees in its size. It is given as a question that arc AP equals to arc CB in its length. Repeat again. According to what is given as a question, arc AP equals to arc CB in its length. So here we can implement rule 56. Repeat quickly on rule 56. If two arcs are equal in their lengths, then their corresponding chords are also equal in their lengths. Again, if two arcs are equal in length, then their corresponding chords are also equal in their lengths. So in the drawing, we have a circle. This is arc AB. That is equal to this arc CB in its length. So those two arcs are equal to each other in their lengths. And therefore, their corresponding angles must be also equal to each other in their sizes. Okay, in their sizes. Chord AB is the corresponding angle of this arc, and chord CD is the corresponding angle of this arc. And therefore, according to rule 56, chord AB must be equal to chord CD in its length. Okay. So we can implement rule 56 in our drawing. Because now avoid according to what is given as the question, arc PA equals to arc CB in its length. So we join points A and P together by straight line. So the corresponding chord of this arc AP is chord AP, and the corresponding chord of this arc CB is chord CB. And according to Rule 56, the corresponding chords of those two arcs must be also equal to each other in their lengths. That is to say, chord PA equals to chord CB in its length. So according to Rule 56, chord CV equals to chord PA. But it is given as the question that this is chord CB and it equals to 5 units in itself. So you can write here that CV equals to 5. And for this equation, 5 equals to CB equals to PA. We know that chord PA must be also equal to 5 units in its length. So actually, this is called PA, is equal to 5 units in its length. In the next step, we join points P and C together by straight line. By joining points P and C, we can do triangle triangle ACP. So this is triangle ACP. That subtend on chord P8 is equal to 5 units in its length. Likewise, this is the other triangle. This is actually triangle CAB that subtend on chord CB, and it is also equal to 5 units in its length. Because of the fact that those two triangles subtend on equal chords, therefore they must be equal to each other on their sides. So that is to say, triangle PCA must be equal to triangle CAB in its side, according to Rule 57. According to Rule 57, triangle PCA is equal to this triangle CAB in its side, according to Rule 57. Is equal to this triangle CAB. So if you define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other according to to rule 57. In the next step, we focus on this right green triangle PQC. This right green triangle PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this right lower triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha, according to the sum rule that said that the sum of the angles in any triangle is equal to 180 degrees. So this first angle must be equal to 90 degrees minus alpha. In the next step, we report that those two triangles, those two right angles, are similar to each other according to angle similarity rule. That is why we report that this is the green triangle PCQ that is similar to this right lower triangle ABC according to angle similarity rule. So write those two right angles are similar to each other. First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So if you prove that all the triangles of this green triangle PQC are correspondingly equal to all the angles of this big right triangle ABC. So at the moment, if you found out that this is the green right triangle PCQ, and is similar to this right lower triangle ABC. If you found out that the green right triangle PCQ is similar, this is the sign of similar to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive side PQ of this right rectangle PQC over side CB of this right rectangle ABC is equal to side QC of this green rectangle PQC or side AC of this right rectangle ABC. So PQ or CB equals to QC or AC. PQ or CB equals to QC or AC. And again, from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of the green right triangle PQC over side CB of the right triangle ABC equals to side OC, side the QC of the green right triangle PQC over side AC of the right triangle ABC. PQ is the missing side, so we leave it as it is. Well, CB is 5, and it is equal to QC 6 over AC. AC in total equals to x plus 6. So again, we found out that PQ over 5 equals to 6 over x plus 6. So here we multiply the equation by 5. And finding again that the missing side PQ is equals to 5 times 6 is 30 over x plus 6 . And again, if you know that the length of this side PQ is equal to 6 over x, actually it is, we multiply this equation by 5 and therefore it is 30 over x plus 6 units in its length. It is given us a question that AC is a straight line. So if we focus on the upper side of the straight line AC at point Q, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the areas on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle that is the right angle, plus this missing angle, total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we implement a pattern on this right smooth triangle APQ. Here by PT is a motion for quadration. So in this right triangle APQ, according to the product theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in this right triangle APQ, AP squared, that is the square of the hypotenuse, is equal to PQ square plus QA square. Repeat again, this right triangle PQA according to the product theorem, AP squared, that is the square of the hypotenuse, equals to QC square plus QA square. Repeat again, in the right triangle APQ, according to the product theorem, we should find out that AP squared, that is the square of the hypotenuse, equals to PQ square plus AQ square. AP is 5, therefore AP squared is 5 squared, it's 25. And it is equals to PQ square. PQ is 30 over x plus 6, and therefore PQ square is equals to 30 over x plus 6 squared. Plus QA square. QA is x, therefore Q square is x square. So to that we should find out that $25 equals to 30 over x plus 6 square plus x square. So 25 equals to, here we open the brackets of this expression, 30 over x plus 6 square equals to 30 square, that is 900 over x plus 6 square. Plus x square. So 25 equals to 900 over x plus 6 square, and here x square. So here we multiply x square by x plus 6 square, and then we divide it by x plus 6 square in order to overcome factor with this expression. So we have plus x square times x plus 6 square, then we have to divide it by, we divide it also by x plus 6 square, so we get nothing. Here we multiply the equation by x plus 6 square and find that 25 times x plus 6 square equals to 900 plus x square times x plus 6 square. So we'll open the brackets on both sides of this equation and get that 25 times x plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x, and it equals to 900, and we have times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. So here we open the brackets on this side of this equation, and we get that 25 times x squared is 25x squared. We have 25 plus 46 is 900. We have 25 times 12x is 300x. And it equals to 900 plus 900 plus x squared plus 46 plus 12x times x squared. So here we have 900 on both sides of this equation, so 900 will get cancelled. After you cancel 900, on this side of the equation we'll have to live with 25x squared plus 300x, and it equals to, here we will open the brackets of this expression. X squared times x squared is x to the power of 4 plus x squared times 36 is 36x squared. And we have x squared times 12x equals to 12x cubed. Here we subtract 25x squared from this equation. And finally we get that 300x equals to x to the power of 4 plus 12x to the power of 3, and we have also plus 36x squared, and 36x squared plus 25x squared equals to 11x squared. So in total we should now know that 300x equals to x to the power of 4 plus 12x cubed plus 11x squared. So here we subtract 300x from this equation. And finally get that x to the power of 4 plus 12x cubed minus 300x equals to 0, and we also plus 11x squared. Again, in total we shall know that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we will take x as a common factor from those two expressions. So inside the brackets we will have x cubed plus 12x plus 11 minus 300 equals to 0, plus 11x minus 300 equals to 0. This equation, x times x cubed plus 12x is actually plus 12x squared plus 11x minus 300 has two solutions. The first solution for this equation is that x equals to 0, and if x equals to 0, then 0 times anything is 0. And the second solution to this equation is that this expression equals to 0, and 0 times x is 0. So the second solution for this equation is that x cubed plus 12x squared plus 11x minus 300 equals to 0. Okay. Actually, x can never be equal to 0, and for the fact that x is the length of line side AQ, so x as a length, it must be a positive number, and therefore cannot be equal to 0. That is definitely not a positive number. So repeat again, x is the length of line segment AQ, so x as a length, it must be a positive number. Therefore, x can never equal to 0. So the next step, we'll check whether if this equation is the solution as a solution. That is to say, we'll check that if x equals to 3 is the solution to this equation. That is to say, we substitute x in this equation by 3. So if x equals to 3, x cubed is 3 cubed, that is to say it is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9. 9 times 12 is 108. And we have plus 11x, x is 3, so 11x is 11 times 3, that is 33. And we have also minus 300, and it should be equal to 0, it must be equal to 0. $27 plus 108 plus 33, in total it is 168. So we have 168 minus 300 must be equal to 0, but 168 minus 300 is definitely not equal to 0. So the solution that x equals to 3 is not correct solution. In the next step, we check what is the value of this expression for x equals to 4. Or if x equals to 4, solve this equation. And if x equals to 4, then x cubed equal to 4 cubed, that is 4 times 4 times 4. This is actually 64. And we have also 12x squared. X is 4, so x squared is 4 squared, that is 16, and 16 times 12 is 192. We have plus 11x. X is 4, so 11x is 11 times 4, that is 44. Plus 300. It should be equal to 0. According to this equation, 64 plus 44 is 108, and 108 plus 192 is 300. 300 plus 300 equals to 0. So if you found out that x equals to 4 is the solution of this equation. Okay. And therefore, we can present this expression in a different way. So we have this expression, is actually x cubed plus 12x squared plus 11x minus 300 equals to 0. And again, you have the second solution to this equation, that this is actually x cubed plus 12x squared plus 11x minus 300 equals to 0. And because of the fact that x equals to 4 solves this equation, then this expression in total is equal to x minus 4 times x squared plus 16x plus 75, and it should be equal to 0, while because of the fact that those two expressions are identical, and this expression equals to 0, then this identical expression must be also equal to 0 too. Now, it is very easy to solve this equation. Here we will have two solutions that are possible to solve this equation. The first solution for this equation is that x minus 4 equals to 0. X minus 4 equals to 0. And if x minus 4 equals to 0, then 0 times anything is 0. So you get that 0 equals to 0. So the first solution to this quadratic equation is that x minus 4 equals to 0. We add 4 to this equation, so we get that x equals to 4 units in itself. So the first solution for x is that line segment AQ is equal to x is equal to 4x in its length. But the second solution to this equation is that this expression equals to 0, and 0 times x minus 4 is 0. So we have to check whether if x squared plus 16x plus 75 is going to be equal to 0 or not. So x squared plus 16 x squared plus 16x plus 75 equals to 0 is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula for quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. Okay. The solution to this general quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2. Write it down again here. We find out the variable x that we are looking for this general quadratic equation according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. This expression inside the root is defined as the determinant of this quadratic equation, and if that is to say b squared minus 4 times a times c is the determinant of this quadratic equation. And if a determinant of a quadratic equation is a negative number, the quadratic equation has no solutions at all. So now we check for our specific quadratic equation, that is to say x squared plus 16x plus 75 equals to 0. What is the determinant of this quadratic equation? If the determinant of this our specific quadratic equation is a negative number, it means that this quadratic equation has no solutions at all. The coefficient a of this our specific quadratic equation equals to 1. The coefficient b equals to 16, and the coefficient c equals to 75. Therefore, the determinant of this quadratic equation is actually b squared minus 4 times a times c. b is 16, therefore b squared is 16 squared, it is 256 minus 4 times a times c. So it is minus 4 times a is also minus 4 times 1 is minus 4 times c is 75, and minus 4 times 75 is minus 300. So the determinant of this our specific quadratic equation equals to 256 minus 300. That is definitely a negative number, and therefore it means that this quadratic equation has no solution at all. Okay? It means that there is no x that is a real number that can solve this quadratic equation. And because of the fact that this quadratic equation has no solution at all, the second solution to this equation is an incorrect solution. So we cancel the solution because why? The quadratic equation has no solution at all. And we left only with one solution to the question, that is to say, the length of this line segment AQ equals to x is equal to 4 units. So AQ is equal to x is equal to 4 units in its length. So we finished to answer the first question. In the next step, I'll present you the second question and we'll solve the second question of this lecture. Actually, we can prove in a different way that our specific quadratic equation is actually x squared plus 16x plus 74 equals to 0. There's no solution at all, but in order to save time, why not present the second way to prove that this quadratic equation is no solution at all. In the second question, our task is to find out the area of this quarter circle A or B. So in the drawing, we have quarter circle A or B. This is line segment PQ, this is equals to 4 units in its length. This is line segment AQ, this is equals to 4 units in its length. This is angle PQA, this is a right angle. Again, our task is to find out the area of this quarter circle A or B. So, first of all, OA equals to OB, they're both the radius of this quarter circle and therefore they are equal to each other. We will define the radius of this quarter circle as R. So, the radius of OA equals to R. And the radius of OB also equals to R according to our definition. We have a rule that says that in front of equal sides in the triangle there are equal angles. So if you focus on the right triangle A or B, in front of those two equal sides, we have those two angles that must be also equal to each other in their sizes. So if we define the size of this angle as x, then the size of this angle must be also equal to x because they are equal to each other according to the rule that I mentioned. And we have the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in this right triangle A or B? X plus x is 2x plus 9 degrees. In total it must be equal to 180 degrees. So write it down. In the right triangle A or B, the sum of the angles must be equal to 180 degrees. That is to say, 2x plus 90 degrees in total must be equal to 180 degrees. Listen again. The sum of the angles in the right triangle A or B must be equal to 180 degrees. That is to say, 2x plus 90 degrees, in total the sum of those figures must be equal to 180 degrees. Here we subtract 90 degrees from this equation. And we get that 2x equals to 180 degrees minus 90 degrees is 90 degrees. So 2x equals to 90 degrees. Here we divide this equation by 2 and get that the missing angle x equals to 90 degrees over 2 is 45 degrees. Okay, this is the missing angle x is equals to 45 degrees in size. And this is also the missing angle x is equals to 45 degrees in size. In the next step, we will do a construction. This is to say from point O, that is the center of this quarter circle, we will draw perpendicular on AB. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point O and AB. This point is point M. By doing this construction, we can do the right triangle AMO. In the right triangle AMO, the sum of the rest must be equal to 180 degrees. So which angles we have in the right triangle AMO? We have 45 degrees plus 90 degrees is 135 degrees. So 135 degrees plus the size of this third missing angle, total must be equal to 180 degrees. And therefore this third missing angle must be equal to 45 degrees in its size. Why? Because 135 plus 45 is 180 degrees. That is the sum of the angles in any triangle. So this third missing angle must be equal to 45 degrees in its size. And therefore the right triangle AMO is also an associated triangle. And we have the rule that says that in front of equal angles in a triangle, they are equal size. So if we relate to the right and associated triangle AMO, we get that according to the rule I mentioned, in front of those two equal angles, we have those two sides that must also equal to each other in their lengths. This is to say, AM equals to MO. Again, AMO, AM equals to OM according to the rule dimension. In front of equal angles in the triangle, they are equal size. So AM equals to OM. AM equals to OM. We define the length of this line segment QM as X. So AM in total equals to 4 plus X. So you can write here that AM equals to 4 plus X. And on this equation, 4 plus X equals to AM equals to OM. We know that side OM must be also equal to 4 plus X units in its length. So this is the missing side OM. This equals to X plus 4 units in its length. The next step, we will implement the Pythagoras theorem on this right triangle, right and associated triangle, triangle AMO. Here by PT is the version for Pythagoras theorem. So this right triangle AMO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to AM squared So according to the Pythagoras theorem, this right triangle AOM, right in the associated triangle AOM, AO square, that is the square of the hypotenuse, equals to AM square plus OM square. But again, in this right and associated triangle AOM, according to the Pythagoras theorem, AO square, that is the square of the hypotenuse, equals to AM square plus OM square. AO is the missing side, so we name it as it is, so it is AO square equals to AM square. AM is X plus 4, and therefore AM square is X plus 4 square plus MO square. MO is also X plus 4, and therefore MO is X plus 4 square. And so now we should follow that AO square equals to X plus 4 square plus X plus 4 square. So AO square equals to X plus 4 square and plus X plus 4 square is 2 times X plus 4 square. Here we'll take a look at this equation. And finally get that the missing hypotenuse AO is equal to the square root of 2, and the square root of X plus 4 square is X plus 4. So AO equals to the square root of 2 times x plus 4. AO is the opposite of the right and associated triangle AMO, but AO is also the radius of this quarter circle. And therefore, we found out that the radius of this quarter circle R equals to the square root of 2 times x plus 4 units in itself. So write it down. The radius R equals to the square root of 2 times x plus 4 units in itself. In the next step, we will do another construction, that is to say, we draw perpendicular on line 7 PQ at point P. Again, we will draw perpendicular on this short line 7 PQ at point P. So actually, this angle equals 90 degrees according to our construction. And we will extend the perpendicular OM by side line until it touches this extended perpendicular P. And we will define the touching point of the extended line OM with the extended perpendicular from point P. This point is point N. According to what is given as the equation, AB is the side line. So if we focus on the upper side of the side line AB, it's point Q. Here the sum of the areas must be equal to 180 degrees according to Rule 3. Rule 3 said that the sum of the areas from one side of the side line is equal to 180 degrees. So which areas we have at the upper side of the side line AB at point Q? We have this angle that is the right angle, plus this angle, and total the sum of two angles must be equal to 180 degrees according to Rule 3. Therefore, this angle must be equal to 90 degrees in its size. Likewise, OM is a perpendicular, so OM is a perpendicular, it is absolutely a side line. When you extend the side line by side line, the result ON must be also a side line. So ON is a side line. So if you focus on the lower side of the side line ON is point M, the sum of the angles must be equal to 180 degrees according to Rule 3. So which angles we have on the lower side of the side line ON at point M? We have this angle that is the right angle plus this angle, total the sum of those two angles must be equal to 180 degrees according to Rule 3. Therefore, this angle must be equal to 90 degrees in size. So in this small quadrilateral NMQB, we have 1, 2, 3 address. And therefore, this form must be equal to 90 degrees in size according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral NMPQ we have 4 degrees, and therefore we can write to quadrilateral NMQP is 30 degrees. Okay. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NMQP, side PQ must be equal to the opposite side NM. But PQ is 3, therefore the opposite side NM must be also equal to 3 in its length. Likewise, according to the sum rule, in the same rectangle NMQP, side QM must be equal to the opposite side PN. But QM is x, and therefore the opposite side PN must be also equal to x units in its length. In the next step, we will join points O and P together by side line. What is the definition of line segment OP? Line segment OP starts from point O, that is the center of the quarter circle, and then ends at point P, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, OP is the radius of this quarter circle. We already found out that the radius of this quarter circle R equals to the square root of 2 times x plus 4 units in its length. So in the next step, we will implement the Pythagoras theorem on this right triangle, triangle NPO. And again, we will implement the Pythagoras theorem on this right triangle, triangle PNO. Here by PT is the brochure for Pythagoras theorem. So in this right triangle P and O, according to the Pythagoras theorem, we get that PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. Repeat again, this right triangle P and O according to the Pythagoras theorem. PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. The hypotenuse PO equals to the square root of 2 times x plus 4. And therefore, the square of the hypotenuse, that is to say PO squared, must be equal to the square root of 2 times x plus 4 squared. And it is equal to Pn squared. Pn is x, therefore Pn squared is x squared. So Pn squared equals to x squared plus NO squared. NO in total equals to OM, that is x plus 4, plus Mn, that is 3. So in total, NO equals to x plus 7. Therefore, NO squared equals to x plus 7 squared. And then in total, we found out that the square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. Here we will open the brackets on both sides of this equation. And we get that the square root of 2 squared is 2. And you also times x plus 4 squared. and it is equal to, so it is, the square root of 2 squared is 2 times x plus 4 squared. We have to square also the second expression. So we have to square all the expression inside the brackets. So in total, we actually found out that this expression, square root of 2 times x plus 4 squared, in total it is equal to 2 times x plus 4 squared, and it is equal to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared is 49 plus 2 times x times 7, that is plus 14x plus 2 times x times 7 is 14x. Here we open the brackets of this expression and get that it is 2 times x plus 4 squared equals to x squared plus 4 squared is 16 plus 2 times x times 4, that is 8x, and it equals to x squared plus x squared is 2x squared, so it is equals to 2x squared plus 49 plus 14x. Here we will open the brackets of this equation. We get that 2 times x squared is 2 times 2x squared. 2 times 16 is 32. And 2 times 8x is 16x. On the other side of the equation we have 2x squared we have 2x squared on the other side of the equation we have 2x squared plus 49 plus 14x. So here we have 2x squared on both sides of the equation, so 2x squared gets cancelled. So we cancel 2x squared, and this side of the equation we have only with 32 plus 16x, and it is equal to 49 plus 14x. So now, if you found out that 32 plus 16x equals to 49 times 14x. So here we subtract 14x from this equation, and so you get that 32 and 16x plus 14x is 2x, so 32 plus 2x equals to 49. Here we subtract 32 from this equation, and finally we get that 2x equals to 17. Here we divide this equation by 2 and find out that x equals to 17 halves. this is side Bn is equals to x and it is equals to 17 absent. Likewise, Qm is equal to x is also equals to 17 absent in itself. Our task is to find out the area of this quarter circle. So what is the area of this quarter circle? So our test is to find out the area of this quarter circle AOB. The area of any quarter circle equals to pi times the radius of the circle squared over 4. Because the quarter circle is 1/4 of a circle. Therefore, we have to divide the area of the circle pi squared by 4. That will be the area of the quarter circle AOB. So it is pi over 4 times the radius of the circle squared. The radius of the circle is also the radius of the quarter circle, of course, and the radius is square root of 2 times x plus 4. Therefore, the radius square is square root of 2 times x plus 4 square. So, the area of this quarter circle AOB equals to pi over 4. And we'll open the brackets of this expression. We get that square root of 2 squared is 2 times x plus 4 squared. Two over 4 is 1/2, so this expression equals to pi over 2 times x plus 4 squared. We already found out that x equals to 17/2. So we substitute x here by 17/2. And we get that the area of this quarter circle AOB total equals to pi over 2 times x plus 4 squared. X is 17/2 plus 4 squared. So it is pi over 2 times 17/2 plus 4. So we multiply 4 by 2 and then we divide by 2 in order to become factor with this number. 4 times 2 is 8. Then we divide it by 2, so we change nothing. 8 over 2 is of course 4 square. So the area of quarter circle AOB total equals to pi over 2. Inside the brackets we have 17 plus 8 is 25 over 2 squared. So the area of quarter circle AOB total equals to pi over 2 times 25 over 2 squared. 25 over 2 squared equals to 25 squared, that is 625 over 2 squared, that is 4. So it is equal to we have in the numerator of 625 pi over 2 times 4, that is 8. 625 pi over 8 equals to 245.437 square units in its size. So in total we found out that the area that we are looking for this question, that is the area of this quarter circle AOB, is equal to either 625 pi over 8 square units in size, or in terms of numbers it equals to 245.437 square units in size. So we finish to answer on the second question. In the next step I will start the lecture, that is to say, we repeat on the solution of the first question, and then we repeat on the solution of this second question. In the first question, our task is to find out the area of this short line segment AQ that equals to x. We have to find out the value of x. So in the drawing, we have semicircle APCB. You know that this is angle PQC, this is right angle. This is line segment QC, this equals to 6 units in there. This is line segment QC, this equals to 6 units in there. This is line segment CB, or chord CB, this equals to 5 units in there. In addition, we know that this is arc PA, this is equals to arc CB in its length. Again, those two arcs are equal to each other in their lengths. Again, our test is to find out the length of this short line segment AQ is equals to x. We have to find out the value of x. So this is peripheral angle ACB. It's subset on the diameter of this semicircle, and therefore it must be equal to 90 degrees inside according to rule 7. According to rule 7, any peripheral angle that subset on the diameter of the circle or semicircle must be equal to 90 degrees inside. Peripheral angle ACB subset on chord AB, that is the diameter of the semicircle, and therefore it must be equal to 90 degrees inside according to rule 7. So this is the right angle. It is given us a question that those two arcs are equal to each other in their lengths. That is to say, arc AP equals to arc CB in its length. The rounded sign above AP and CB is the sign for arc. It means that arc AP equals to arc CB in its length. So, here we implemented rule 56 in our drawing. First of all, we join points P and A together by side 9. In this way, we created chord PA. The corresponding chord of this arc PA is chord PA, and the corresponding chord of this arc CB is chord CB. And according to rule 56, if two arcs are equal to each other in their lengths, then the corresponding chords must be also equal to each other in their lengths. That is to say, those two arcs are equal to each other in their lengths, and therefore their corresponding chords must be also equal to each other in their lengths. That is to say, chord PA equals to chord CB in its length according to rule 56. Meaning again, because of the fact that arc AP equals to arc CB in its length, then the corresponding chords must be also equal to each other in their length. That is to say, chord CB equals to chord PA in its length. But it is given us the question that chord CB equals to 5 units in its length. So we can write here that CB equals to 5. And for this equation 5 equals to CB equals to PA, we will derive that chord PA must be also equal to 5 units in its length. This is chord PA equals to 5 units in its length. In the next step, we join points P and C together by straight line. By joining points P and C, we can do peripheral angle PCA. This is peripheral angle PCA that subset on this chord PA that equals to 5 units in its length. Likewise, we have another peripheral angle that's actually peripheral angle BAC that subset on this chord called BC is also equals to 5 units in its length. And because of the fact that those two peripheral angles subset on equal chords, is equals to 5 units, they must be equal to each other in their sizes. That is to say, peripheral angle PCA equals to peripheral angle CAB in its size according to rule 57. So those two peripheral angles must be also equal to each other and their sizes. So if you find the size of this peripheral angle PCA is alpha, then the size of this peripheral angle PAC must be also equal to alpha because they are equal to each other according to rule 57. So in this again right triangle PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, 90 degrees plus 90 degrees, this is equal to 180 degrees, that is the sum of the angles in a triangle. Likewise, in the right lower triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. According to the sum, the set and the sum of the angles in a triangle is equal to 180 degrees. So, in the next step, we prove that this is the right triangle PQC, and it is similar to this right lower triangle, triangle ABC. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So if you found out that all the angles of this green right triangle PQC are corresponding equal to all the angles of this right lower triangle, triangle ABC. Therefore, those two right triangles are similar to each other according to angle similarity rule. And again, if you found out that the right green triangle PCQ is similar, this is the sign of similar, to the right lower triangle, triangle ABC, according to angle similarity rule. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this right triangle PQC over side CB of this right lower triangle ABC is equal to side QC of this right triangle PQC or side AC of this right lower triangle ABC. We derive from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side PQ of the green triangle or side CB of the right lower triangle ABC equals to side QC of the green triangle or side AC of the right lower triangle ABC. PQ is the missing side, so we leave this it is. CB is 5, QC is 6, and AC in total equals to x plus 6. So AC is x plus 6. So in total, if you found out that PQ over 5 equals to 6 over x plus 6. Here we multiply this equation by 5, and finally found out that the missing side PQ equals to 6 times 5 is 30, so in total this expression equals to 30 over x plus 6. With the end, this is the missing side PQ or side PQ. This equals to 30 over x plus 6 units in its length. It is given as a equation that AC is a straight line. So if we focus on the upper side of the straight line AC at point Q, the sum of the angles must be equal to 180 degrees according to all three. All three state that the sum of the angles on one side of the sum of the angles of one the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have on the upper side of the straight line AC point Q? We have this angle that is right angle plus this missing angle. Total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 90 degrees in its size. And therefore triangle PQ is a right angle. So we implemented the Pythagoras theorem on this right triangle PQ. According to the Pythagoras theorem, in any right triangle the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So in the right triangle APQ, AP squared is the square of the hypotenuse equals to PQ squared plus QA squared. Repeat again, this right triangle APQ according to the Pythagoras theorem, AP squared is the square of the hypotenuse equals to PQ squared plus QA squared. AP is 5, therefore P squared is 5 squared, that is 25, and it equals to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared plus QA squared. QA is x, therefore QA squared is x squared. So in total, we found out that 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to this expression squared. So we open the brackets of this expression. 30 over x plus 6 squared equals to 30 squared, this is 900, over x plus 6 squared, plus x squared. So total, if you found out that 25 equals to 900 over x plus 6 squared. So here we multiplied x squared by x plus 6 squared, then we divided it by x plus 6 squared in order to work conform solving this expression. So we have here 25 equals to 900 over x plus 6 squared, then we multiply x squared by x plus 6 squared, then we divided by x plus 6 squared, so we change nothing. So in total, if you found out that 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. Here we multiply this equation by x plus 6 squared, and finally found out 25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared plus x squared times x plus 6 squared. So we have 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, then this is 12x, and it equals to x squared, it is equals to 900 plus x plus 6 squared, 900 times x squared times x plus 6 squared. So it is x squared times x plus 6 squared. X plus 6 squared equals to x squared plus 36 plus 12x. We open the brackets of this expression. 25 times x squared is 25x squared. 25 plus 36 is 900. And we have 25 times 12x is 300x. The other side of the equation we have 900, and we have this expression that is actually x squared times x squared plus 36 plus 12x. We open the brackets of this expression, and finally found out that x squared times x squared is x to the power of 4. And we have x squared times 36 is 36x squared, and we have x squared plus 12x is 12x cubed. So here we have 900 on both sides of this equation, so 900 we can cancel, and we cancel 900. This side of the equation we left only with 25x squared plus 300x, while on the other side of the equation we left with x cubed plus 36x plus 12x x to the power of 4 plus 36x squared plus 12x cubed. So here we subtracted 25x squared from this equation. So in this side of the equation we left only 300x equals to x cubed, and we have 36x squared minus 25x squared is 11x squared plus 12x cubed. So in total, if you found out that x equals to x to the power of 4 plus 12x cubed plus 11x squared, and it is equals to 300x. So here we subtracted 300x from this equation, and finally we found out that x to the power of 4 plus 12x cubed plus 11x squared plus 300x equals to 0. So here we took out x as a common factor from those four expressions, so inside the root we left with x squared plus 12x squared plus 11x minus 300 equals to 0. So here we have two solutions that are possible for x. The first solution for x is that if x equals to 0. If x equals to 0, 0 times anything is 0. We get that 0 equals to 0. So the first solution for this equation is that x equals to 0. And the other side of this, the other solution to this equation is that this expression equals to 0. 0 times anything is 0. So we get that 0 equals to 0. So the first solution for x is that x equals to 0. And the second solution for this equation is that x cubed plus 12x squared plus 11x minus 300 equals to 0. So first of all, x can never be equal to 0. Why? Because of the fact that x is the length of line segment AQ. So x as a length, it must be a positive number. And again, x is a length, and x as a length, it must be a positive number. So it can never be equal to 0. That is not a positive number. So the first solution for x is the correct solution. X can never be equal to 0. We have also the other solution for x, to this equation. If the expression inside the brackets is 0, then 0 times x is 0, and again the 0 equals to 0. So the second solution for x is that the expression inside the brackets equals to 0. That is to say, x cubed plus 12x squared plus 11x minus 300 equals to 0. First of all, we checked if x equals to 3, solve this equation. That is to say, we substitute x by 3. And therefore, if x equals to 3, it means that x cubed equals to 3 cubed. 3 cubed is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9, and 9 times 12 is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, minus 300 equals to 0. 27 plus 108 plus 33, in total it is 168. And we have 168 minus 300 is definitely not equals to 0. So if x equals to 3 is not the solution to this equation, because the left side of the equation is not equal to the right side of the equation, therefore it is not a solution to this equation. In the next step, we checked if x equals to 4 is the solution for this equation. That is to say, substitute x by 4. X cubed is 4 cubed, that is actually 4 times 4 times 4, that is 64, plus 12x squared. X is 4, so x squared is 4 squared, that is 16, times 12. 16 times 12 is 192, plus 11x. X is 4, therefore 11x is 4 times 11, that is 44, minus 300 should be equal to 0. 64 plus 44 is 108, so 108 plus 192 is 300, and 300 minus 300 is 0. So if x equals to 4, solve this equation. And therefore, actually, we can present this equation in a different way. So our expression is x cubed plus 12x squared plus 7x minus 100 equals to 0. This is the solution to the original equation. This expression is identical to this expression. If you just open the brackets of this expression, you will get that those two expressions are identical. Therefore, we can substitute this expression by this expression that is identical to it. So this expression equals to 0, and therefore this expression must also equal to 0 because those two expressions are identical. Now it is very easy to solve this equation because here we have two solutions to this equation. The first solution for this equation is that x times 4 equals to 0. If x times 4 equals to 0, then 0 times anything is 0, and we get that 0 equals to 0. And the second solution to this equation is the expression in the brackets, inside the brackets, equals to 0. 0 times x times 4 is 0, and we get that 0 equals to 0. So the first solution for this equation is x times 4 equals to 0. If we add 4 to this equation, we get that x equals to 4. So the first solution to the equation is that this is like saying a cubed equals to x and x equals to 4. We have another solution to this equation. We check if the other solution to this equation is correct solution. That is to say, we check if x squared plus 16x plus 75 equals to 0. Actually, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the value that we are looking for. And we get the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. The expression inside the root is b squared minus 4 times a times c. And the expression inside the root, that's actually b squared minus 4 times a times c, is the determinant of the quadratic equation. And if the determinant of any quadratic equation is a negative, then the quadratic equation will not have a solution at all. So we must verify that the determinant of our specific quadratic equation is not negative. In our specific quadratic equation, that is to say x squared plus 16x plus 75 equals to 0, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. And therefore, the determinant of this our specific quadratic equation equals to b squared minus 4 times a times c. b is 16, therefore b squared is 16 squared, that is 256, minus 4 times a times c. So it is minus 4 times a is 1. So minus 4 times 1 is minus 4 times c. c is 75, so minus 4 times 75 is minus 300. So in total, minus 4 times c is minus 300. 256 minus 300 is a negative number, that is to say, the determinant of our specific quadratic equation, that is to say x squared plus 16x plus 75 equals to 0, the determinant of this quadratic equation is a negative, and so this quadratic equation has no solution at all. And therefore, the second solution to this equation is the incorrect solution. And we're left only with the only solution that is possible for this equation is that x equals to 4. And therefore, the answer to the question is that 970 cubed equals to x is equal to 4 units in itself. So I finish to repeat on the first question. In the next step, I repeat on the solution of the second question. In the second question, our task was to find out the area of this quarter circle A or B. So in the drawing, we have quarter circle A or B. This is the short line side P cubed equals to 4 units in itself. This is line side A cubed equals to 4 units in itself. This is angle PQ8 is the right angle. Again, our task is to find out the area of this quarter circle A or B. First of all, OA equals to OB, the above the radius of the quarter circle, and therefore they are equal to each other. So if we define the radius of this quarter circle as R, then OA equals to R, and OB also equals to R. So in this right angle A or B, those two sides are equal to each other. And we have the rule that says that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides in this right angle A or B, there are those two equal angles. So if you find the sides of this angle as x, and the sides of this angle must be also equal to x because they are equal to each other according to the rule that I mentioned. We know that the sum of the angles in a triangle is equal to 180 degrees. So in the right triangle A or B, x plus x, that is 2x plus 9 degrees, in total must be equal to 180 degrees. So in the right triangle A or B, 2x plus 9 degrees equals to 180 degrees. Here we subtract 90 degrees from this equation, and we found out that 2x equals to 180 degrees minus 90 degrees is 90 degrees. Here we divided the equation by 2 and found out that the missing angle x equals to 9 degrees over 2 is 45 degrees. This is the missing angle x, this is 45 degrees, and this is also the missing angle x, this is also 45 degrees inside. In the next step, we did the construction, that is to say, from point O, we go perpendicular on AB. So this angle equals to 9 degrees, and this angle also equals to 9 degrees according to our construction. We define the touching point of the perpendicular from point O and AB, this point is point M. By doing this construction, we get the right triangle AMO. In the right triangle AMO, the sum of the angles must be equal to 180 degrees. So 45 degrees plus 9 degrees is 135 degrees. 135 degrees plus the sine of this 4 angle in total must be equal to 180 degrees. According to the rule that the sum of the angles in a triangle is equal to 180 degrees. And therefore this first angle must be equal to 45 degrees inside. So the right triangle AMO is also this triangle. We have the rule that in front of equal angles in the triangle, they are equal size. So in front of those equal angles in the right triangle AMO, we have those two sides that must also equal to each other in the reverse. That is to say, side AM equals to side MO. And again, the right triangle AMO, in front of equal angles, we have equal sides. That is to say, side AM equals to side OM. But if we define the length of QM as x, then AO in total equals to AQ, that is 4 plus x. AM in total equals to 4 plus x. So we can write that AM equals to 4 plus x, and from this equation 4 plus x equals to AM equals to OM, we will derive that OM must also equal to x plus 4 in its length. This is the missing side OM, this equals to 4 plus x in its length. In the next step, we implement the Pythagoras theorem on this right triangle AMO. So in this right triangle AMO, according to the Pythagoras theorem, AO squared is the square of the hypotenuse equals to AM squared plus MO squared. So again, in the right triangle AMO, according to the Pythagoras theorem, AO squared is the square of the hypotenuse equals to AO squared, AM squared plus MO squared. AM is x plus 4, therefore M squared is x plus 4 squared. Likewise, OM is also x plus 4, therefore OM squared is x plus 4 squared. So in total, AO squared equals to x plus 4 squared plus x plus 4 squared, that is 2 times x plus 4 squared. So AO squared equals to 2 times x plus 4 squared. Here we took out all those equations and found out that AO equals to the square root of 2 times x plus 4 units in its length. AO is the radius of this quarter circle, is equals to the square root of 2 times x plus 4 units in its length. In the next step, we did another construction, that is to say, we go perpendicular on this line segment PQ at point P. Again, we go perpendicular on this line segment PQ at point P. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular OM by side line until it touches the perpendicular from point P. And we find the touching point of the extended perpendicular OM with the perpendicular from point P. This point is point N. Here we implemented the rule 3 twice. We found out that those two angles are both right angles according to rule 3. That said that the sum of the angles on one side of the straight line is equal to 180 degrees. So in quadrilateral NMQP we have 1, 2, 3 angles. Therefore this 4 angle must be equal to 90 degrees inside. Therefore in quadrilateral NMQP we have 4 angles, and therefore quadrilateral NMQP is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PNMQ, side QM must be equal to the opposite side PN. But QM is x, therefore the opposite side PN must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle PQMN, side PQ must be equal to the opposite side MN, but PQ is 3, therefore the opposite side MN must be also equal to 3 units in its length. In the next step, we join points OP together by side line. OP is the radius of the quarter circle, equals to the square root of 2 times x plus 4. And then we implemented the Pythagoras theorem on this right triangle PNO. this right P0. P0 squared is the square of the hypotenuse equals to Pn squared plus NO squared. Repeat again, in the right triangle NO. In the right triangle P0. P0 squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. PO is the radius of the quarter-circle, that is square root of 2 times x plus 4, and therefore P squared equals to the square root of 2 times x plus 4 squared, and it is equals to Pn squared. Pn is x, therefore Pn squared is x squared plus On squared. On is x plus 7, therefore On squared is x plus 7 squared. We open the brackets of this expression, so this expression in total equals to 2 times x plus 4 squared, and it's equals to x squared plus x squared. We have x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. We have 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. And we have x squared plus x squared is 2x squared plus 49 plus 14x. Open the brackets on this expression. We have 2 times x squared, 2 times 16 is 32, and 2 times 8x is 16x, and it equals to 2x squared plus 49 plus 14x. We have 2x squared on both sides of this expression, so 2x squared will get cancelled. 2x 2x squared, 2x squared, and this side of the equation we have only with 32 plus 16x, while on the other side of the equation we left only 49 plus 14x. So in total we should find out that 32 plus 16x equals to 49 plus 14x. So here we subtract 14x from this equation, and finally found out that 32 equals to 2x plus 32 plus 2x equals to 49. Here we subtract the 32 from this equation, and finally found out that 2x equals to 17. Here we divided this equation by 2, and finally found out that x equals to 17 halves. X equals to 17 halves. Our task is to find out the area of this semicircle, quarter-circle. Quarter-circle AOB. The area of the quarter-circle AOB equals to pi times the radius of the circle squared over 4. So it is pi over 4 times the radius of the circle squared. The radius of the circle or quarter-circle is square root of 2 times x plus 4, and the radius squared is square root of 2 times x plus 4 squared. So it is pi over 2, and we have square root of 2 times x plus 4 squared. This is actually square root of 2 squared, this is 2 times x plus 4 squared. 2 over 4 is 1 half, so in total this expression equals to pi over 2 times x plus 4 squared. So it is pi over 2, which substitute x by 17 halves. So it is 17 halves plus 4. In total, the area of the quarter-circle equals to pi over 2 times 17 halves plus 4 squared. Pi over 2 times 17 halves plus 4 squared. So it is pi over 2 times 17 halves. Here we multiply 4 by 2, and then we divide it by 2 in order to come out with this number. 4 times 2 is 8, divided by 2. 17 plus 8 is 25. So in total, the area of the quarter-circle equals to pi over 2 times 25 over 2 squared. So it is pi over 2 times 25 over 2 squared. 25 over 2 squared equals to 25 squared, that is 625, over 2 squared, that is 4. So in total, in the numerator of this expression, we have 625 pi over 2 times 4, that is 8. So in total, we should find out that the area that we are looking for in this question, that is the area of this quarter-circle AOB, equals to either 625 pi over 8 square units in size, or in terms of numbers, the area of this quarter-circle equals to 245.347 square units in size. Okay, thank you very much.